All right, so we're talking about rational numbers. The definition of a rational number is any number that can be written as a fraction. So obviously all fractions, improper or proper, so you'll notice you got things like this. They can be negative as well. Okay. Decimals can be written as a fraction, most of them. So if you had like 1.25, you could turn that into 1 1/4, and then turn that into 5/4. They all have to be in A over B form. Okay, is the definition of a rational number. Some numbers, like repeating numbers, there's no way to turn that into a rational number. Okay, pi is an example that goes on forever, is an example of an irrational number. Okay, so the definition that can be turned into a fraction. Kind of some random properties we're going to learn here. Okay, so we have the what's called the inverse property of addition, which basically is said the sum of a number and its additive inverse, which is a fancy word for opposite, is 0. So essentially all that's saying is if you add a number with its opposite sign, it's going to be 0. So 5 plus -5 is 0. Add a number with its opposite, it's going to be 0. That's called the inverse property of addition. Another property is called the identity property of addition, and that says the sum of a number and the additive identity, which is a fancy word for 0, is the same number. Pretty simple concept. If you add a number with 0, you're going to get the same thing. -7 plus 0 is still -7. So nothing super complicated here. Okay, some multiplication properties. The product of a non-zero number and its multiplicative inverse, which is a fancy word for reciprocal, is 1. So basically, if you multiply a number by its reciprocal, you're going to get 1. So if you multiply a number by the flipped version, by the reciprocal, you're going to get 1. So for example, 3 over 4 times 4 over 3 equals 1. That's called the inverse property of multiplication. Finally, the identity property of multiplication basically says is the product of a number and the multiplicative identity is the number. In this case, instead of 0, it's going to be 1, because if you multiply something by 0, you get 0. So for multiplication, we all know this. You multiply a number by 1, you're going to get the same number. So here's an example of that. So first off, let's show that a number is rational by writing it A over B form. So that, in this case, would be, oops, just make it into a fraction. For these, we don't want anything out front. Seems kind of silly, but if you have a negative number out front, tack it on to one of the numbers, either top or bottom. So we kind of just have just the A over B form. Now, 0.625. Let's remember how to write things as a fraction. Remember, take the last place value. It's the thousandths. Oops. That's going to be your denominator, and then we need to, of course, always reduce. I'm going to try 25 here. 625 divided by 25 is 25. 625 divided by 25 is 25. And that is 40, so we didn't quite get the GCF on the first try there. So we're going to have to reduce again by dividing by 5. And getting 5 over 8 would be my rational form of that in reduced form. So some further examples of using the multiplicative inverse. Are, to use these familiar properties. So, for example, if you have negative, let's make this another example, negative 10.6 plus 3 plus negative 4.4. Well, we could do some things here. we could move these guys next to each other so that we have a little bit easier time. So -4 would give us -15, and that's a little easier to work with. So you don't have to add 2 decimals at once. So that would give you -12. So what about here? So if we had another example, we had 2/3. And so what we did here, by the way, is we used the commutative property. Would be an example of using a property in our favor. So let's see here. Always want to be looking for if there's any opposites that could be combined together so they cancel each other out, any reciprocals that could be combined. So we could use the commutative property, which basically says you're just allowed to switch things, to add these two additive inverses together. And so basically those are going to equal 0 because of our additive inverse property. And then our identity property says anything plus 0 is going to give us the same thing. So that would be an example of both additive properties here. So, oops, where my page get added? Just going on another blank page here. I'm going to drop down. Our last example is if we have -5/3 times 7/4 times 4/7. So we could know, oh, we have reciprocals. We know those are going to cancel out just to equal 1, which because of our multiplicative inverse property, any reciprocals equal 1. And then our identity property says anything times 1 equals itself. So we can use those properties to quickly solve a problem.